On behalf of the planning team that includes representatives for the USDA Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we thank you for your interest in the planning study for Settingdown Creek Dam No. 6. This is the second public meeting to develop the Supplemental Watershed Plan environmental assessment for this dam. The purpose of this study is to assess the Settingdown Creek 6 watershed and evaluate the performance of the dam. To also develop a plan to address compliance issues with the dam and determine if federal financial assistance will be available to address compliance issues. Also, the study will determine if the project sponsor would like to continue operation of the dam within the NRCS watershed program. The planning study includes a public participation plan. The objective is to inform the public and watershed stakeholders of the planning effort. The planning study requires a series of public meetings. The first public meeting was held in August 2020. The initial public meeting presentation included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed and specific dams included in the planning study, and finished with the opportunity for members of the public to submit questions and comments for the various scoping topics in order to identify project opportunities and concerns. Please note that if you missed the initial public meeting, that presentation has been reposted to Schnabel's YouTube channel for those interested in viewing the presentation and the content described above. That presentation and responses to the questions and comments received during the initial presentation will be posted on Schnabel's YouTube channel through early January 2021. This second presentation will discuss the following topics: an overview of the Settingdown Creek watershed, the existing conditions associated with Settingdown Creek Dam No. 6, a discussion of rehabilitation alternatives under consideration for Settingdown Creek Dam No. 6, and the opportunity for members of the public to submit questions and comments regarding the alternatives presented. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. Settingdown Creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage area. The original watershed work plan, prepared in April 1954, provided for the construction of 15 floodwater retarding structures, also known as the Settingdown Creek Dams. This slide presents a map of the Settingdown Creek watershed. The watershed boundary is delineated by the red line. For reference, Georgia 400 or US Highway 19 is located at the east or right side of the map. The upstream portion of the Settingdown Creek watershed is also located at the east end of the map or right side of the map. The Etowah River, for reference, is located near the left or west side of the map. For additional reference, please note the locations of Keith Bridge Road, Georgia Highway 9, Georgia Highway 369, Canton Highway, Georgia Highway 20, and Post Road, all located in northern Forsyth County. This slide presents an aerial photograph of the Settingdown Creek watershed taken in 1963, shortly after the construction or during the construction of several of the dams in the Settingdown Creek watershed. Note that significant residential and commercial development has occurred over the past 60 years within the watershed. This development will change the function and performance of the dams due to new runoff conditions and changes to the basin. As part of the Supplemental Watershed Plan preparation, there are several focal points of analysis and study, including upstream areas to determine flooding and the need for additional storage capacity, downstream areas which could be subject to flooding and/or within the limits of a dam breach zone should the dam fail in a catastrophic manner. Also, as part of the study, is an evaluation of the hydraulic capacity of the existing spillway outlet works for the dam. This evaluation was performed during several storm events, including large design storm events required by the Georgia Safe Dams program and the NRCS. In addition to the engineering analyses performed to support this study, an evaluation of the economic and social benefits provided by the dam is also being performed. Also, an environmental assessment, including the identification of cultural resources within the project vicinity, is also being performed. Once again, here's a map of the Settingdown Creek watershed. There are 6 dams that are currently included in the current planning study. Those watersheds and dams are delineated by the various colors. 5 of the dams are located at the most upstream portion of the watershed. Dam number 6 is also located at the upstream end of the watershed. Settingdown Creek Dam number 6 meets Georgia Safe Dams program criteria to be considered a Category 1 high hazard dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam needs an operating permit from the Safe Dams program. Previous assessments and studies indicate that this dam does not comply with current SDP rules and requirements. This dam is not exempt from SDP rules and requirements. One purpose of the Supplemental Watershed Planning Study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety regulations. The Georgia Safe Dams program is fully aware of this dam, its classification or pending classification as a high hazard dam, and that the dam is being studied by the planning team. Some of the original design features of the dam include the fact that the dam was not originally designed as a high hazard dam. The primary purpose of the dam is flood mitigation, and an anticipated secondary purpose of the dam was sediment accumulation and storage. The spillways for the dam include a reinforced concrete principal spillway comprised of a riser structure in the lake and a concrete pipe or conduit through the embankment to convey flow from the riser structure in the lake through the dam to the outlet channel downstream of the dam. Finally, the spillway outlet works include a vegetated earthen auxiliary or emergency spillway that is meant to engage during periods of high rainfall to pass flows around the dam without allowing the dam to overtop. The location of Settingdown Creek Watershed Dam number 6 is indicated is outlined in yellow on this map. Note that it is at the upstream end of the watershed near 4 other dams that are included in the planning study at this time. Settingdown Creek Dam number 6 is located east of Hopewell Road and west of Georgia 400. Constructed in 1957, the dam is approximately 63 years old. The dam is 33 feet tall and has a drainage area of 0.88 square miles. The design storage capacity of the dam is 360 acre-feet, with considerations for storing sediment, flooding, and surcharge above the auxiliary spillway elevation. This 1963 aerial photo presents the dam shortly after its construction and impoundment of the lake upstream of it. As you can see, there are lots of agricultural interests around the dam at this time and not a tremendous amount of development. Over the past decades, changes in the watershed, including development, have occurred around the dam. This aerial photo is a current aerial photo, and you'll note the location of some residential subdivisions and commercial development in and around the watershed for dam number 6. This summer, to support the planning effort, a topographic survey of the dam was performed. The topographic survey was performed to determine the elevations of the dam crest and critical spillway outlet works. An aerial photo to support the development of the topographic survey was taken this summer after the dam was cleared of trees and inappropriate vegetation by the sponsor. You'll note that this view of the dam is oriented such that the lake is at the bottom of the page and downstream areas are at the top of the page. Left and right with regard to these directions is referenced in this manner. This is an existing site plan using GIS topographic contour information to display the dam and spillways. Note that the location of the existing principal spillway, riser, and pipe is near the left end of the dam. The existing auxiliary spillway is located at the right end of the dam. There's a relatively wide floodplain downstream of the dam as the tributary enters into Settingdown Creek. These photos were taken this summer after the dam was cleared. Please note the locations of the riser structure in the lake, the upstream slope of the dam, and the crest of the dam. This photo shows the outlet end of the principal spillway conduit where it discharges into a plunge pool. The downstream slope is to the right of the photo. In addition to the engineering analyses performed to support this planning effort, an environmental assessment of the dam is being performed. This summer, an environmental survey of the dam was performed. The fieldwork determined that no protected species were found during the survey. However, some invasive species, predominantly Chinese privet, were located in a couple of areas upstream and downstream of the dam. The Aquatic Resource Survey map at the left side of this slide indicates the location of streams, wetlands, open water, and invasive species observed in the vicinity of the dam. Also, a Phase 1 Cultural Resources Survey was performed. The survey involved a literature review and field activities, including shovel tests. During the field activities, no archaeological resources were identified or recorded. The dam, on the order of 63 years old, is the only historic resource, but it is not eligible for the National Registry of Historic Places. The Cultural Resources team recommends that no additional cultural resource work be performed for this structure. As part of the planning effort, a dam breach analysis was performed for the dam. This map indicates the location of the inundation zone downstream of the dam were the dam to fail in a catastrophic manner. To perform the dam breach analysis, the planning team utilized a sunny day breach scenario, assuming that water would be at the top of the dam and the dam would fail in that manner. The red houses indicated on the inundation map show the locations of potential structures or hazards that would be impacted if the dam were to fail in this manner. This slide presents a downstream flood analysis map of the upper portion of the Settingdown Creek Watershed. Note the location of Settingdown Creek Dam No. 6, as well as the locations of other dams in the watershed. The dams work together to provide flood benefits to downstream areas along Settingdown Creek. This map shows the limits of inundation associated with both the 100-year and 500-year storm events, as well as the locations of structures that may be impacted during these events. A downstream flood analysis is important to the planning study because the dams currently provide flood benefits to several areas downstream of the dams. Modification to the dams, their spillways, or removal of the dams would impact the amount of flood benefits currently provided by those dams. This slide presents an upstream flood limits map of the dam. The planning team, using information about the dam, its storage volume, and its spillway outlet works, modeled several storm events and passed those storm events through the dam and spillway outlet works. This map indicates the maximum water surface elevations for 4 storm events that were studied, including the 100 and 500-year storms, the Safe Dams Program design storm, which is 1/3 of the PMP, and the NRCS design storm, which is the freeboard hydrograph, or 100% of the PMP, or probable maximum precipitation. In addition to the limits of the storm inundation upstream of the dam, the normal pool elevation of the lake, the auxiliary spillway control section elevation, and the dam crest elevation are also indicated on this map. Note that there are no structures below the top of dam. However, during the freeboard hydrograph, structure 1, which is a cell phone tower, is slightly impacted by flooding upstream of the dam. Existing dam deficiencies. The dam was recently cleared during the summer of 2020. Prior to its clearing, the dam had overgrown with trees and inappropriate vegetation. An underwater inspection of the riser structure concluded that portions of the slide gate assembly are worn or covered in marine growth. The commercial divers that performed this inspection noted that the gate was covered by accumulated sediment and was not completely accessible. Portions of the riser structure concrete are cracked and/or spalling. A CCTV inspection of the principal spillway conduit interior is pending, which will be used to evaluate the condition of that pipe. Regarding existing hydraulic deficiencies, previous studies indicated that the dam did not meet Safe Dams Program criteria. An enhanced analysis of this dam, including an evaluation of the earthen auxiliary spillway channel, determined that the existing dam is capable of safely storing and passing the Safe Dams Program design storm event with adequate freeboard. This means that little hydraulic improvements to the dam are required to meet Safe Dams Program criteria. Regarding NRCS criteria, the auxiliary spillway engages prior to the PSH storm event. The principal spillway hydrograph is the PSH storm event. The principal spillway conduit is not capable of meeting the PSH drawdown requirement, and the auxiliary spillway control section is 3.6 feet lower than is required by NRCS standards. During the design storm event, the dam overtops by 1 foot and the earthen auxiliary spillway channel breaches. Using NRCS planning techniques, several rehabilitation alternatives have been developed and are being evaluated and considered by the planning team. One of the alternatives that requires study is the future without project or no action alternative. This alternative assumes that federal financing will not be available to rehabilitate the dam. Therefore, funding to rehabilitate the dam to Georgia Safe Dams Program criteria standards would come from state or local resources. Other alternatives that are being considered include decommissioning the dam, which would involve removing a portion or the entirety of the earthen embankment. This alternative would also involve stabilizing the excavated channel and resulting lake bed. It could require floodproofing and/or relocation of downstream hazards, given that the dam currently provides flood benefits to downstream areas. Several structural rehabilitation alternatives are also being considered. These alternatives would meet NRCS design storm criteria and also involve improvements to the embankment and principal spillway systems. In most cases, the auxiliary spillway would need to be widened or raised to meet the larger design storm criteria associated with the NRCS design storm. These auxiliary spillways could be earth cut or concrete spillways, such as Labyrinth spillways or roller compacted concrete step spillways with various types of crests. The development of NRCS rehabilitation alternatives includes consideration of upstream non-flood controlled ponds, as well as uncertainties with rainfall events over the next 50 to 100 years associated with climate change. The first alternative that we will discuss is the federal without project or no action alternative. As stated previously, Settingdown Creek Dam No. 6 is currently capable of safely storing and passing the Georgia Safe Dams Program design storm, which is 1/3 of the PMP. However, several of the components, namely the principal spillway, are aging and require replacement. This alternative would include regrading the upstream and downstream slopes of the dam to a 3-to-1 slope to improve maintenance, and the construction of a riprap-lined wave berm along the upstream shoreline of the dam to reduce wave action erosion along the embankment. A new principal spillway would be constructed, including a riser structure and a new conduit through the dam, with a riprap-lined plunge pool at the downstream end of the conduit. Based on the current configuration of the auxiliary spillway, no modifications are necessary to pass the Georgia Safe Dams Program design storm event. This slide provides a conceptual plan of the Safe Dams Program alternative. Note that there's some grading shown to improve the uniformity of the slopes, and the location of the riprap-lined wave berm on the upstream slope of the dam is also indicated. A new principal spillway constructed within the extents of the current principal spillway would also be involved in this alternative. Here's a profile view of a proposed principal spillway that would meet Safe Dams Program criteria. An NRCS alternative that was considered was the use of the existing vegetated auxiliary spillway. This alternative was considered and determined to be infeasible due to the nature of the modifications to the vegetated auxiliary spillway necessary to meet NRCS requirements. This means that based on NRCS requirements, the vegetated auxiliary spillway would need to be raised or widened an excessive amount to meet the requirements of the NRCS design storm event. A decommissioning alternative is also being considered by the planning team. This alternative would involve reconfiguring the existing structure so that it would no longer be classified as a dam. The process is more involved than simply breaching the dam. Decommissioning the structure would involve removal of most or all of the existing dam, reconnecting the grade of the original floodplain, stabilizing the resulting lake bed with permanent vegetation, and stabilizing the primary channel through the footprint of the old dam with riprap. While decommissioning the structure would improve flooding upstream of the dam, the downstream flood benefits provided by the dam would be lessened. The planning team is evaluating and quantifying the downstream benefits currently provided by the dam, as well as the loss of those benefits were the dam to be removed. This conceptual site plan indicates removal of the dam and reconnection of the floodplain. Note that the original outlet channel through the footprint of the dam would be lined with riprap, and the existing principal spillway system would be removed if this alternative were selected. This slide includes a couple of profile views along the dam baseline and the main creek channel downstream of the dam were the dam to be removed. We've included a couple of photographs with examples of what a decommissioning alternative may look like. Note that the dam has been removed. The majority of the embankment has been removed from this dam. The disturbed areas have been revegetated with turf grass, and that primary outlet channel through the dam has been stabilized using riprap. This riprap line channel would flow on a consistent basis, and water levels through this channel would increase in the event storm events were to occur upstream of the dam or within the watershed of the dam. The first NRCS structural alternative that we will discuss is a labyrinth crested spillway alternative. This alternative would involve raising the crest of the dam to the current maximum water surface elevation associated with the design storm, which is 100% of the PMP. Embankment rehabilitation would also include regrading the upstream and downstream slopes to a 3-to-1 uniform grade, constructing a riprap-lined wave berm along the upstream shoreline of the dam, and closing off the existing vegetated auxiliary spillway with fill up to the top of dam elevation. A new principal spillway would be constructed and the existing principal spillway would be decommissioned. The auxiliary spillway in this alternative would be a reinforced concrete labyrinth crested spillway with a total width of 48 feet, consisting of 2 equal cycles 24 feet wide. The spillway would be constructed over the dam embankment and would separate one side of the crest of dam from the other, so consideration would be given to providing access to both sides of the spillway from the crest. The spillway also includes a reinforced concrete stilling basin and riprap-lined apron to dissipate energy associated with high flow storm events. This slide presents a conceptual layout of the labyrinth spillway to meet NRCS criteria. Note that the principal spillway would be constructed along the footprint of the existing principal spillway, and the new labyrinth crested chute spillway would be constructed to the right of that principal spillway. The existing auxiliary spillway would be decommissioned by filling it up with earth up to the top of dam elevation associated with the NRCS design storm event. This slide presents a profile view of the labyrinth crested spillway. Flows over this spillway would typically engage after the 100-year storm event. Flows would spill over the labyrinth wall at the top of the spillway and then flow down the chute into a stilling basin at the downstream end. Before entering the floodplain, a riprap apron would be constructed between the concrete stilling basin and the natural floodplain. The next couple of photographs present examples of labyrinth crested spillways constructed over existing earthen embankments. The first photograph shows an aerial view of a dam with a pedestrian bridge over the top to provide access from one side of the crest to the other. This photograph also does a good job of illustrating how the outlet channel from the auxiliary spillway would reconnect to the downstream floodplain and original stream channel. The photograph of this labyrinth spillway indicates how a principal spillway can be constructed upstream of the labyrinth spillway with its pipe discharging through the chute of the labyrinth crested spillway. Access from one side of this spillway to the other is provided along the upstream side of the spillway and can be had during times of low flows into the lake or normal pool water surface conditions. The final NRCS structural alternative that we will discuss is a roller compacted concrete stepped spillway alternative. The dam would have similar embankment and principal spillway rehabilitations as the labyrinth crested spillway. The major difference would be that the auxiliary spillway would consist of a broad crested roller compacted concrete stepped spillway. The total width of such a spillway would need to be on the order of 160 feet wide, and the RCC steps would have a height of 1 foot. The spillway would be constructed over the embankment similar to the labyrinth, with consideration given to providing access to both sides of the spillway from the dam crest. A stilling basin and riprap-lined apron would also be constructed downstream of the stepped spillway. This site plan shows a conceptual view of an RCC spillway that meets NRCS design criteria. Note that the principal spillway is in the same location as the existing spillway, and that the RCC spillway would be constructed over the embankment just to the right of the principal spillway. The existing auxiliary spillway would be decommissioned in this alternative by placing fill up to the top of dam elevation. This slide presents a profile view of the RCC step spillway with a broad crest. The RCC steps will be constructed on a 3-to-1 slope, and a sidewall would contain flows over this spillway. Water would spill through the broad crest at the top of the spillway and down the RCC steps into the stilling basin and riprap apron before re-entering the floodplain downstream of the dam. The next couple of photographs show examples of RCC step spillways. This RCC step spillway is constructed over an embankment, and the stilling basin downstream of the steps has been filled with topsoil and grass. Since these spillways would typically engage during storm events greater than the 100-year storm event, some dam owners elect to fill in portions of the spillway with topsoil and grass to improve appearance of the dams and maintenance. Here's another example of an RCC step spillway over a dam where topsoil and grass have been placed over the steps and the stilling basin of the spillway. This particular spillway has an OG crest, which is a rounded crest to improve the hydraulic performance of a straight weir. This photograph shows a good view of the rounded top of the OG crest. This final photograph once again shows how an RCC spillway can be constructed over an existing embankment. This dam was constructed over an existing principal spillway, and the pipe for the principal spillway discharges into the stilling basin of the RCC step spillway. The sponsor for this dam elected to fill the steps on the spillway with topsoil and grass. This photograph was taken during construction when the grass over the steps was establishing. That concludes our presentation of rehabilitation alternatives being considered by the planning team at this time. Project stakeholders and you, the public, are invited to submit questions, concerns, and comments regarding the plan development and rehabilitation alternatives. Questions, concerns, and comments may be submitted by accessing a Google form at the web address provided below. Questions, concerns, and comments associated with this public meeting will be accepted through Monday, January the 4th, 2021. Once again, we would like to thank you for your interest in the planning study for Settingdown Creek Dam No. 6. Please take advantage of the opportunity to submit questions and comments, and have a good day.